Hello guys, my name is Upendra Das and today I am going to take a lecture on the topic work, power and energy. So let us start with the work. What is the definition of work? Simply you can say that a scalar product of force and displacement is known as work. But before knowing this definition, how it comes from numerical portion, let us discuss with some blocks. So let us start. Suppose that I am taking a block at point A. This is point A, and at this point a block is kept. And now we are going to apply a force F in positive X direction. Just because of this force, what will going to happen? The block is going to move in this direction, along the direction of the applied force. The block will move somewhere at this point B. Now suppose that if there is a displacement between A and B is S, because force means what? Force means push or pull of a body. If you are applying force, definitely the block is going to move, and they have different motions, but we'll discuss it about the types of forces and everything later on. But today our topic is work, that's why we are discussing only about the work chapter. So look at here, we have applied a force F on the block A, or on the block which is at point A, and due to the application of this force, the body is going to move at the point B with a displacement of S. So initially its velocity was 0. It means that the block was at rest. But when you have applied the force F, what happens? The block moves, and during its motion there will be some velocity, there will be some final velocity. So we are going to calculate that what was the final velocity of that body. We have learned about the different equations of motions in the laws of motion chapter. That is, first is V equal to U plus AT, second is S equal to UT plus half AT square, and third one V square is equal to U square plus 2AS, right? These are the three equations, but I am going to use this third equation. Look at here, for the calculation of the final velocity. Now V square is equal to U square plus 2AS. Initial velocity of the body is 0, so you may write 0 here, plus 2 into acceleration. What is the formula for the acceleration? If you want to calculate, if force is given, then you can easily calculate the value of acceleration, that is force per unit mass, where m is the mass of the block. This is the mass of the block, and mass of any body is always constant, it does not change. So at point A its mass is m, and at point B also its mass will be m. So it is not going to vary anyway. So acceleration, you may write for the acceleration F upon m, and S is your displacement. So V square comes to be here 2F dot S divided by m. So you can write here 2F into S is equal to mv square, or you can write F dot S equal to mv square upon 2. So this is the product of force and displacement. Force and displacement, that comes to this quantity. The product of force and displacement, as we already know, this is the work done on a particle due to the application of any force. If you are applying any force on a body, and if the body changes its position from one point to another point, then the product of force and displacement is known as work done by that force. Okay, so this is the work done, and the formula that we have get here, that is 1 by 2 mv square. What does it mean? That means work done is equal to 1 by 2 mv square. This quantity is known as kinetic energy. This is kinetic energy. So what do you mean by kinetic energy? The energy of a body. Suppose that if there is any body, and if that body is at rest, So what kind of energy it possesses? It possesses a potential energy, because already we know that energy of a body due to its position is known as potential energy, and the energy of a body due to its motion is known as kinetic energy. Here we have applied a force F, and because of the application of that force F, its position changes, and there will be some motion, and because of that motion will get kinetic energy. So you can also say that kinetic energy of the body is equal to the work done, or you can say that change in kinetic energy is equal to the work done, but it will I will describe it later on by using the differentiation and integration method. So look at here. Suppose that the formula that I got from this method, 1 by 2 mv square, this is kinetic energy. Now suppose that I am going to differentiate this kinetic energy with respect to the time. So how it will be further? 1 by 2 mv square, instead of v we write here 2v dv upon dt. I am differentiating this v square. So after differentiation, dk upon dt is equal to mv dv upon dt, and dv upon dt means acceleration. As we already know that acceleration means rate of change of velocity with respect to the time. So m, and this is acceleration a, and velocity is there, so m into a is force and this is velocity. So dk upon dt comes to be f dot v, or you can also write like this, dk is equal to f v dt, right? And instead of velocity, if somebody will ask you that what do you mean by velocity, then you can say that rate of change of position with respect to the time, that is known as velocity. So instead of v, we will write here f is equal to v is equal to dx upon dt. Here dt will cancel out, and finally we will get f dot dx. So f dot dx, as I have already told you, that the product of force and displacement is the work done. So you can write instead of f dot dx here dw. dw means a small amount of work is done by that force. So work done can be calculated by calculating the change in kinetic energy, and by integrating you will get the total work done as well as total kinetic energy too. 1 2 1 2, this is the integration, will get the total work done, and change in kinetic energy will be k2 minus k1. So this is a very simple process to calculate work done, or calculate work done by using a kinetic energy. So this is all about the process, a very simple step to calculate work done. If some body is given and if it is moving by the application of some force, then you can easily calculate it by the help of change in kinetic energy and is equal to work done formula. So that's all, and later on we'll describe about the power as well as energy. That's all.